Hello everyone. Today we are going to study about binary to gray code converter and gray to binary code conversion. So, what is binary to gray code converter? So it is a logical circuit that used to convert binary numbers into equivalent gray code. Now what is gray code? So gray code system is a binary number system only, in which every successive pair of numbers differs in only one bit. Now this is the combination. Binary numbers means ones and zeros or ones. So here gray code is also binary number system, but here a successive pair of numbers are differ in one bit. For example, we will see one example. The representation of decimal value 1 in binary will be 001, and 2 will be 010. But in gray code, this representation of 1 and 2 is equals to 001 and 011. This that way, incrementing a value from 1 to 2 requires only one bit to change instead of two. So here only one bit is changing instead of two. So this is called gray code equivalent. Where we need this binary to gray code converter. So here it is used in the application in which the normal sequence of binary number generated by the hardware may produce an error during the transmission from one number to next number. So during transmission from one number to next number, whenever the hardware generates that binary number, it may produce an error. So here, and this gray code eliminates this problem, since only one bit is changing during the transmission of two bits. Now how to convert this binary number to gray? So these are the four uh, bit binary number. Suppose I have 4-bit binary number 1001, that is b3, b2, b1 and b0. These are the 4-bit binary numbers. We have to convert it into equivalent gray code. So the first rule is the msb will always be same as the first bit of given binary number. So this is my first bit, that is most significant bit. So this is my most significant bit of binary number. So in gray code, the first bit will be same as the first bit of binary number. So this one will be same. So here b3 will be G3 will be same as b3. So the first bit of gray code G3, that is same as the first bit of binary number, that is b3. So G3 is equals to b3. Now, to find out G2, that is a second bit of gray code, we have to perform XOR between first bit of binary number and second bit of binary number. So this is my first bit B3, and second bit of binary number is B2. So we have to perform the XOR operation between B3 and B2 to get G2. What is XOR operation? So it means if the both bits are different, then this result will be 1, and if the both bits are same, the result will be 0. So to get now, in order to get third bit, now how to find out first bit? So b3 G3 is equals to b3, then second bit G2 will be the XOR between b3 and b2. To get G1, we have to perform the XOR operation between b2 and b1. So b2 XOR with b1 will give you G1, and similar and the same for the next bit. So fourth bit, so G0 is fourth bit. So how to get G0? So B1 XOR with B0 will give you G0. So here in this manner, we have to convert binary into gray code. Write down the equations. So G3 is equals to B3. Then G2, what is G2? G2 is B3 XOR with B2. So G2 is equals to B3 XOR with B2. Then G1 is equals to B2 XOR with B1, and G0 is equals to B1 XOR with B0. We will see one example. This is my 4-bit binary number 1010. Now we have to find out the equivalent gray code. So first MSB bit, this is my MSB bit will be as it is. So 1, it will be 1. Then to find out the next bit, we have to perform the XOR operation. This is my XOR gate truth table, where if the both inputs are same, the output will be 0, and if the both inputs are different, the output will be 1. So here, to get another gray next bit of gray equivalent, we have to perform the XOR operation between first and second bit. So 1 XOR with 0 will give you 1. Then 0 XOR with 1 will give you 1 XOR with 0 will give you 1. So this is my binary number 1010, and equivalent gray code will be 1111. So in this manner, we have to perform for all combinations. This is my 4-bit binary number, and this is equivalent 4-bit gray code. So the first rule, first is MSB bit will be same. So B3 will be same, G3 will be same as B3. So G3 is equals to B3. Then to find out B2, we have to perform the XOR between B3 and B2. So 0 XOR 0 will give you 0. Then 0 XOR 0 will give you 0. And 0 XOR with 0 will give you 0. Then next, for next bit, 0 XOR with 0 will give you 0, 0 XOR with 0 will give you 0, and 0 XOR with 1 will give you 1. Next, 0 XOR with 0 will give you 0, then 0 XOR with 1 will give you 1, and 1 XOR with 0 will give you 1. Similar manner, we have to find out for all the remaining combinations. Next, we circuit diagram of binary to gray code conversion. So what is G3? Accord, see, G3 is equals to B3. So B3 is equals, G3 is equals to B3. Now G2 is B3 XOR with B2. So this is my B3, and this is my B2. This is the XOR gate. So G2 is equals to B3 XOR with B2. Then B2 XOR with B1 will give you G1, as G1 is equals to B2 XOR with B1, and G0 is B1 XOR with B0. So here this is my B1 and this is B0. So B1 XOR with B2 will give you G0. So this is the circuit diagram of binary to gray code conversion. Now, how to convert gray to binary? So gray to binary code converter is also logical circuit which used to convert the gray code into equivalent binary code. Now, how to convert this? So to convert gray code to binary, the first, bring down the most significant digit of a given gray code number. Like first bit is as it is, because the first digit or most significant digit of gray code is same as the binary number. So suppose this is my 4-bit gray code, I have to convert it into binary. So the most significant bit, this is most significant bit, which is as it is, so 1 as it is. So here, and to obtain the second bit, we have to perform the XOR between first bit of most significant digit of binary to second bit of gray code. Suppose this is my 4-bit gray code G3, G2, G1, G0. So the first bit will be as it is, so B3 will be same as G3. To find out B2, how to find out B2? So the we have to perform the XOR operation between first bit of binary number. This is my first bit binary number and second bit of gray code. So this is the gray code. So to find out B2, we have to XOR, we have to perform XOR operation between B3 and G2. So we'll get B2. Then similar manner, to find out B1, we have to perform the XOR operation between B2 and G1 will give you B1. Then B1 XOR with G0 will give you B0. So this is the equations. B3 is equals to G3. Then B2, how to find out B2? So B2 is nothing but B3 XOR with G2. So B3 XOR with G2, and B1 is B2 XOR with G1. So here B2 XOR with G1, and B0, how to find out B0? So we have to perform the XOR operation between B1 and G0. So B0 will be B1 XOR with G0. Now from this equation we can draw the circuit diagram. So this is the circuit diagram where um, see B3 is equals to G3. So this is B3 and G3. So B3 is equals to G3. Now B2 is equals to G3 XOR with G2. So this is my B3. Okay. So B3 XOR with G2 will give you B2. Next, to find out B1, so B1 is B2, this is B2, B2 XOR with G1 will give you B1, and this is my B1. So B1 XOR with G0 will give you B0. So B0 is equals to B1 XOR with G0. So this is the gray to binary code converter circuit diagram of gray to binary code conversion. We will see one example. So here this is my 4-bit gray code, that is 1 0 0 1, and we have to convert it into binary equivalent. So how to convert it into binary equivalent? So here first bit will be as it is, that is 1, then 1 XOR with 0, 1 XOR with 0 will give you 1, then 1 XOR with 0 will give you 1, and 1 XOR with 1 will give you 0. So this is my equivalent binary code. Hope you have understood how to convert binary to gray and gray to binary.